Hello, hello. It's me, Hugo. This is valid parentheses. Not really sure why it's this far into it. I guess makes sense, kinda. It stacks mostly. That's the important thing about it. But I don't know. It just felt like such a. It's not really. Well, I mean, it kind of is beginner, right? I'm pretty sure it's easy, right? Yeah. So it's kind of surprising to see it this far into 301, but it's cool. This is valid parentheses. Valid parentheses, pretty simple problem. All you're basically doing is confirming whether or not the parentheses are valid. Parentheses are considered valid if an opening bracket is closed by the same type. Opening brackets must be closed in the correct order. I'll get into that in a little bit. Every closed bracket has a corresponding opening bracket of the same type. So, if we look at the example over here, so in this one we have an opening and closing bracket, but they're different types, so that's false. In this one, it's true because even if we have a nested one, that one closes within the space, so we don't have to worry about it over here. Now, the problem happens, or this is like a unique case, where we have a opening bracket, another opening bracket, and then a closing bracket for the outer opening bracket, and then a closing bracket for the inner opening bracket. That's not allowed. That's considered invalid. So that's the big one that kind of threw me into a pickle at the start when I first started trying to do this problem, and that was before I knew about stacks. So, yeah, we're given a string which contains only characters that are brackets, and the string's length is between 1 and 10,000. So, yeah, nothing crazy about it. The solution that I got uses a dictionary at first. This is a small dictionary though, basically constant space, because it's always going to be just 3 key value pairs. This is just so then it's simpler, quicker, easier to write everything out rather than having to write it all out manually. It just associates the opening brackets with closing brackets. So yeah, I mean, I could have probably done it differently where it was closing brackets with opening brackets, but I feel like the order here is better visually, even if I had to do this weird thing over here, but it's fine. And then we have a stack. Python doesn't have actual built-in stacks, so we just use a list. The list has all the functionality of a stack and other functions too. So I'm just going to use it like a normal stack. Then we're just going to iterate through all of the characters in the string. If the character is in the pairs, which will only look at the keys, so if it is an opening bracket, then we will append that character to the stack. The reason we're looking for it, or the reason we use in pairs, is because it's a dictionary. Dictionaries use are hashed or hash, so we can just quickly do O of 1 lookup. Even if I had to do, okay, even if it's O of 1 lookup, it would still, at worst case scenario, if I just use the list instead, it would just be like 3 maximum, because there's only 3 elements. So it's not really saving that much time, but it's fine. I just think it's more convenient. It looks better visually when you're writing out the code. So, yeah. And then once you have a character that's in the pairs, which is just saying, okay, do we have an opening bracket? Is the current character that we're on an opening bracket? If that's the case, we're going to append it to the stack. The stack is going to keep track of the last opening bracket seen, and it's going to contain the order of them. So this allows us to handle cases like the one over here where we have 2 opening brackets and then 2 closing brackets, but they're not in the right ordering. This forces us to be in the right ordering where we had to match the closing bracket with the appropriate opening bracket. So we're going to keep appending the characters as long as they're opening brackets. Once we don't have an opening bracket, we're going to check if the stack exists. If the stack does exist, that means that there is a character inside of it. So that means we found an opening bracket. If we start off with a closing bracket, we automatically know it's false. This is because if you have a closing bracket at the start, there's nothing to open it ever. So we just skip that. If it fails this condition, that means it already failed this condition up here. It fails this condition, it'll take us immediately down here and return false immediately. It's also important to check that beforehand because we're going to be using stack. We're going to be using or we're going to be looking at an element inside of the stack, and if it's empty, well, that's not good, obviously. It'll cause an error. So if the stack does contain an opening bracket, we're going to be looking at the last element in it. So this is like looking at the top of a stack. And then we're going to be looking at that last opening bracket scene, and we're going to find the character that it's associated with, so the closing bracket it's supposed to have. So we're looking at the opening bracket that we're currently on, or that the last opening bracket that we saw, right? And we're going to be looking at the closing bracket that's associated with it, or that it should have. And we're going to check if the current character is one of those. If it is, that means we found a valid parentheses pair, and we're just going to pop out the opening bracket, and we're going to continue forward without really doing anything to the current character. That was just a check to make sure that that part is valid. The popping of the stack makes it so then we already dealt with the opening and the closing bracket, so now those two are dealt with. We're not dealing with those anymore. Those won't be seen in the future because we're moving forward and we're not going backwards anymore. So yeah, that causes the last opening bracket to be popped out, and then we're going to go to the one before it. So let's say in this case, what's going to happen here is we're going to have this one at the start, and then this one's going to be the last opening bracket that we see. We're going to check the dictionary at that point, which is going to be right here. The value that it's looking for is this closing bracket, and the current character we're on is that one. So what we do is we pop from the stack the last opening bracket that we saw. So we pop this one, which means the last element in the stack is now this one, and then we go to the next character. The next character is this one. So we just look right here really quickly. Okay, this character, so we're going to check it first in the pairs. Is it in the pairs? So the opening brackets, is it an opening bracket? That's not the case. So we go to the else if statement. The stack does contain an element, so we're going to keep going, and then we're going to check for the pair in the last element. So we're going to be looking for the closing bracket associated with this opening bracket, and we're going to check if it's the same as the last bracket that or the character that we're currently looking at. And in this case it is, so we pop it again. And that's when we're finally done. We're at the end of the array, or the string. So then this condition will stop because we've gone through all the characters in the string. We go back over here, and then we're just going to return the length of the stack is equal to 0. This means that we've gone through everything in the stack. It is possible for the stack to have brackets still left over in it. If that is the case, then this will cause it to return false because that means that we have hanging opening brackets. I don't know if there's an example right here. No, there isn't. So an example of this would be like just simply put, I don't know, like that, and then you just have that. So in this case, what's gonna happen here is you're gonna go through it. You're gonna put those two into the stack, then you're going to pop one, then you're going to pop the next one, and then you're going to get this one inside of the stack, and then you're going to exit the for loop because now you're done with all the characters in the string. So now the stack is going to have one character, and it's going to be that. So to make sure that we have to return true only if it's empty, because that means that all the pairs of parentheses, or all parentheses have pairs, or all brackets have pairs. So yeah, that's valid parentheses, and overall it is O of n time because we're only going through the number of characters in the string. We're going through every single one though, so it's O of n. And it's O of n space because the stack, well, is it O of n space? I guess it could be. Yeah, it could be. It could be O of n space. O of n space, worst case scenario. So the stack is going to have the maximum number of elements that the stack is going to have at one time is going to be the maximum number of opening brackets in a row. So if the whole string is just opening brackets, then we're just going to have a stack that's filled with all of the strings. So it's going to be O of n space. But most cases, it's not going to be like that. Most cases, we're going to be popping out things because we're going to find pairs. So we don't really have to worry about that. But worst case scenario, it is O of n space. So O in time, O in space. Pretty good solution overall. And I mean, I've done this a lot of times. So I mean, if we go back, this is a long time ago. This is back when I was printing. Damn. What did I have here? Wait, hold on. Let me look at my code from like when I was in my first semester. I wonder how this looked. Oh no. Switch case? Oh? Wait, did I know about stacks? Damn. Why didn't this work? Is it just because I used cow or see out? Weird. That's weird. This one feels like it should be able to work. I don't know. I mean, the fact that I had a stack makes it so it seems like, what am I doing? I guess this one makes sense because if you have an odd number of brackets, it fails. Huh. I don't know. My brain was doing stuff back then, but yep. I've done this problem multiple times now. I'm glad I still remember it. But yeah.